Certificate authorities are a critical part of the public key infrastructure that allows us to use websites safely. Certificate authorities exist to solve another problem in the communication channel between Alice and Bob. So let's go back to our example where Alice wants to send Bob a private message. And maybe this is me wanting to establish a secure connection to a website that I'm visiting. Remember, the first thing Alice has to do is Alice has to retrieve Bob's public key. So Alice has to ask Bob for his public key, and Bob has to transmit that public key back to Alice. The problem arises because the connection between Alice and Bob requires all of this untrusted internet in between. And someone, let's call them Charles, might be in the middle of this connection. And what Charles does is Charles sees Alice asking for Bob's public key, and instead of letting that request make its way all the way to Bob and be completed correctly, Charles returns his own version of Bob's public key. So Charles, this is something that's known as a man-in-the-middle attack. Charles is claiming to be Bob by exploiting the fact that he's on the network path between Alice and Bob. So when Alice asks for Bob's public key, Charles sends back his own public key. And then Alice will send an encrypted message thinking that only Bob can decrypt it with Bob's private key. But in reality, Charles is going to grab that message as well and decrypt it himself. And he's going to intercept the communication between Alice and Bob. Now, what makes this worse is that Charles can actually do the following. So Charles can forward those messages on to Bob. So Charles can actually get Bob's public key, can take the message from Alice, decrypt it, store the contents. So now I know what they were saying to each other, which is exactly what I didn't want to happen, and still forward the message on to Bob. And so Charles can sit here on the communication path between these two parties and intercept all of the traffic in clear text, which is exactly what we didn't want to happen. So what do we need to solve this problem? So we need some way for Alice to know that she actually got Bob's public key. And so this is where the idea of a certificate authority comes into play. So a certificate authority are these entities that have been established that provide what we can think of as a root of trust. So assuming I trust the certificate authority, what the certificate authority will do is that Bob will go to the certificate authority and say, I want you to validate that this is my public key. And the certificate authority will sign it using its own key. And then when Alice is exchanging data with Bob and she gets this key right here, she'll see that it's not signed properly because Charles is not Bob and Charles can't get the key signed by the certificate authority. So certificate authorities there's this human element. So if you really want to get a strong certificate from a certificate authority, there's usually a process by which they have to validate that you're the business that owns a particular domain, and they might actually talk to you on the phone and things like that. And so there's this human element to it. But at the end of the day, what the certificate authority is going to do is attest that a particular certificate belongs to Bob. So we can see this in action when we go online in our web browser. So let's open up a browser here and do a quick example. Open Chrome. There we go. Okay, so let's go to like Wikipedia or something. All right, so this is wikipedia.org, and you can see up here that the site is green. So this is Chrome's indication to me that this site that my connection with the site is encrypted and that the site is who I think it is. So I'm not being subject to a man-in-the-middle attack. If I click on this, I can pull up more information. So it says my connection to the site is private. It gives me some information about the permissions the site has. But if I click on this, it'll actually start to give me more information. So the page is secure, it's valid HTTPS, and the first thing it says here is view certificate. So the connection to the site is using a valid trusted server certificate. What does that mean? It means that a server that I trust, a certificate authority that I trust, signed the key that I'm using. And so I believe that that key actually belongs to wikipedia.org and not to some other random person who's trying to intercept my traffic. So let's look over here, and again, this will show me more information about the key. If I click details, open this up a bit more. Okay, so I can see that This gives me some sense of how the trust works, and I won't go into details here, but it's certificate authority is allowed to delegate the ability to sign certificates. And so what this says is this certificate was issued by Global Sign Organization Validation CA. It expires, now certificates have an expiration date. This one expires Saturday, December 10th. So the certificate is valid still. And then it gives me some information about the company. So again, in order to sign the certificate, the Wikipedia had to provide some information. Organization name is Wikimedia Foundation. It gives me some information about the issuer name. And then some information about the public key itself. So what this is information that the browser is telling me, and what the browser is saying essentially is that an entity that I trust has verified that this key is the correct key to use when you communicate with wikipedia.org. And that's how we bootstrap trust on the internet and prevent ourselves from being subject to man-in-the-middle attacks.